Chapter 1.11.1 Node Shutdowns. Summary. Nodes in Kubernetes can shut down gracefully with a plan or unexpectedly due to external influences. A graceful shutdown involves the kubelet managing pod termination in two phases, ensuring regular pods and critical pods are stopped sequentially, reducing the risk of workload failures. The shutdown process is configurable and utilizes system D inhibitor locks for managed delays. Activation requires non-zero settings for shutdown grace period and shutdown grace period critical pods. In non-graceful shutoffs, without proper detection, pods might remain stuck or cause errors unless manual mitigation strategies are applied. Feature, pod priority, allows shutdowns with priority class sequence, providing flexible timing per priority. Non-detected shutdowns might need storage detachment intervention after prolonged issues, however, it risks data integrity if not carefully handled. Node shutdowns. A Kubernetes node can shut down unexpectedly, like due to a power outage or in a planned way. If it shuts down without being drained first, it might cause work failures. Node shutdowns in Kubernetes can be either graceful, planned, or non-graceful, unexpected, affecting workloads if not properly managed beforehand. Graceful node shutdown. This code snippet indicates that a pod was terminated in response to an imminent node shutdown due to an external reason such as a power outage. The reason given is terminated due to the impending node shutdown. The code snippet is defining a list of priority levels for pods along with their corresponding shutdown grace periods in seconds. The higher the priority level, the longer the grace period before the pod is terminated during a node shutdown. For example, pods with a priority of 100,000 have a shutdown grace period of 10 seconds, while pods with a priority of 0 have a grace period of 60 seconds before termination. Part 1. Feature Introduction. Kubernetes introduced a feature in version 1.21, enabled by default, to manage pod termination during node shutdown. The kubelet ensures a proper termination process and does not allow new pods during shutdown. Systemed inhibitor locks are used to delay node shutdown, enabling graceful node shutdown controlled by specific feature gates. Part 2. Configuration Options. By default, certain configurations like shutdown grace period and shutdown grace period critical pods are at 0, deactivating graceful shutdown. Activating graceful shutdown requires setting these configurations to non-zero. During shutdown detection, the kubelet marks nodes as not ready, preventing scheduler from assigning new pods. Part 3. Pod termination process. The shutdown process involves the kubelet efficiently terminating pods in two phases, regular and critical pods. Shutdown grace period dictates total delay, while shutdown grace period critical pods specifies duration for critical pods. If node termination is cancelled, already terminating pods must be rescheduled manually. Part 4. Status during shutdown. Evicted pods during graceful shutdown are marked as terminated and show specific status upon inspection. Post-termination, rescheduling is necessary due to non-restoration of pods by kubelet. Running kubectl get pods shows their shutdown status. Part 5. Priority-based shutdown. Kubernetes version 1.24 introduces flexibility to prioritize pod termination using priority classes. The feature allows multiple shutdown phases, adjusting termination based on defined priorities. To enable, set the graceful node shutdown based on pod priority feature gate and configure shutdown grace period by pod priority. Part 6. Monitoring and metrics. Promotes better control by allowing customized shutdown settings per the cluster's pod priority needs. Two metrics, graceful_shutdown_start_time_seconds and graceful_shutdown_end_time_seconds. Record shutdown processes for monitoring. Feature starts as alpha in version 1.23 and becomes beta by version 1.31. Non-graceful node shutdown handling. The Kubernetes system, as of version 1.28, includes a feature that deals with gracefully managing node shutdown. This function helps in managing the downtime of nodes in a Kubernetes cluster. The major challenge addressed here is the detection issues by the kublet's node shutdown manager, primarily due to improper command execution or misconfigured shutdown parameters. If a node shutdown goes undetected, pods belonging to a stateful set may become stuck in a terminating status. This happens because the shutdown node's kubelet is unavailable to delete them and create new instances on a different node. To counteract these issues, users can manually add a taint marking the node as out of service, and forceful mechanisms can delete pods on such nodes, allowing for quicker recovery. In cases of forceful shutdown, pods undergo a two-phase process where they are deleted and their volumes detached. To prevent data issues, users should remove the taint after resolving node issues. Kubernetes has a force detach on timeout option where if a node is unresponsive for 6 minutes, volumes are detached. This setting can be enabled or disabled, but caution is advised due to potential data corruption issues.